To our course Windows Server 2012 Part 12. For today, topic around virtual fiber channel and fiber channel within Hyper-V. You need you need your virtualized workload to connect easily and reliably to your existing storage array. In 2012 fiber channel, we can basically 2012 can provide fiber channel port within the guest OS, which allow us to connect to fiber channel directly within the virtual machine. This feature protects your investment in fiber channel. It will allow us to enable virtualized workload that use direct access to fiber channel storage, allow you to cluster guest operating system over fiber channel, and provide an important new storage option for server hosted in virtualized infrastructure. Now, requirement. The virtual fiber channel feature in Hyper-V requires the following: one or more installation of Windows Server 2012 with Hyper-V role installed, a computer with one or more fiber channel host bus adapter HPAs that have an updated HPA driver to support virtual fiber channel. Updated HPA driver are included with the inbox HPA driver for some modules like Brocade, BR415, 815, QLogic, and QXX25X fiber channel HPAs. Virtual machines configured to use fiber channel adapter, which must use Windows Server 2008, 2008 R2, or 2012 as a guest OS. Connection only to data logic unit number slots. Storage accessed through virtual fiber channel. Connect to LAN and cannot be used as a boot media. Technical overview. Virtual fiber channel for Hyper-V provide a guest operating system with an mediated access to SAN by using standard worldwide name associated with virtual machine. Hyper-V users can now use fiber channel to virtualize workload that require direct access to the SAN and the LANs. Fiber channel SANs also allow you to operate in new scenarios such as running failover clustering feature inside the guest OS of a virtual machine which is connected to a shared virtual fiber channel. Mid-range high and high-end storage array are capable of advanced storage functionality that help to offload certain management tasks from the host to the SANs. Virtual fiber channels present an alternate hardware-based input path to the Windows Software Virtual Disk. This allows us to use advanced functionality which is offered by the SAN directly to the Hyper-V machines. For example, you can use Hyper-V to offload storage functionality, for example, taking a snapshot of a LAN or a SAN hardware using VSS. MPI support. Virtual fiber channel for HyperV Guest uses an existing MPI, which is N-port ID virtualization. T11 standard 2 map multiple virtual import IDs to a single physical channel. A new MPI port is created on the host each time you start a virtual machine that is configured with virtual HPA. When a virtual machine stops running on a host, the MPI port is removed. Virtual SAN support. Hyper-V allow you to define virtual SAN on the host to accommodate the scenarios where single Hyper-V host is connected to different SAN through multiple fiber channel ports. A virtual SAN defines a named group of physical fiber channels which are connected to the same physical SAN. For example, assuming Hyper-V is connected to the two SANs, production and test, this allows us to communicate through physical fiber channel port to these two environments and support around the release management. You can use the same technique to name two separate paths to single storage target. You can also configure as many as 4 Fibre Channel adapters on a virtual machine and associate each one of them with a virtual SAN. Each virtual Fibre Channel adapter connect with one worldwide name address or two WWN addresses to support live migration. You can also set each worldwide name address automatically or manually. Next is the live migration. To support live migration of a virtual machine across Hyper-V host while maintaining Fibre Channel connectivity. Two WWN are configured for each Fibre Channel adapter, as shown below. Set A and Set B. Hyper-V automatically alternate between the Set A and Set B WWN addresses during a live migration. This feature that ensuring all the LANs are available on the destination host before the migration, and that will help us around no downtime occurring during the migration. The following shows alternate WWN addresses during live migration, and you can see the steps involved in the migration between set A and set B. The last part for today is the MPI functionality. Hyper-V 2012 can use multi-path input functionality to ensure continuous connectivity to Fibre Channel storage from within a virtual machine. You can also use MPI functionality with Fibre Channel in the following ways. 1. Virtualized workload that use MPI to install multiple Fibre Channel ports on the host and use MPI to provide highly available connectivity to the LANs. You can also use it to configure multiple virtual Fibre Channel adapter inside the machine and use separate copy of MPI within the guest OS of the virtual machine to connect to the LAN, and the virtual machine can access. This configuration can coexist with a host MPI setup. Last is using a different device specific module DSM for a host or each virtual machine. This approach allows live migration of the virtual machine configuration, including the configuration of DSM and connectivity between host and compatibility within existing server configuration and DSM. This is what I had for you today. Hopefully you learned something around virtual Fibre channels and the technique and the benefit, and I shall see you at the next part, which is part 13. Thank you for listening. Bye.